Hello, everyone, and welcome to Ricky's Math Minute. We're getting ready to start Algebra 2 concept review. In this review, I'm just going to run through a few examples of some common Algebra 2 problems. If there's anything specific that you need to see prior to taking an Algebra 2 final or prior to reviewing for Algebra 2, you can always reach out and I'll be happy to make a video that's geared toward that concept. So without further ado, let's go ahead and get started. It says, this first problem, which expression is equivalent to the fourth root of 8x to the seventh, y to the third, times the fourth root 32, xy to the 10th. The way that we approach this is they are the same, so we're just going to multiply our inner terms together. Okay, so 8 times 32 is going to give us 256, right? And this is still the fourth root. We have x to the seventh times x to the first, so we just add those together. It becomes x to the eighth. Same thing, y to the third, y to the 10th becomes y to the 13th. And then we can still simplify this by taking the fourth root of all of these. Well, the fourth root of 256. So what times itself 4 times equals 256? That's going to be 4. And then root is kind of like dividing exponents. So 8 divided by 4 is going to be x squared. And then 13 divided by 4 cannot be simplified. So we're just going to leave that 13 to the fourth. So we have our answer being D. This is how you're going to approach every problem like this. You do still have to simplify the expression fully after you multiply your inner terms together. Moving on. A couple more root problems. We have number 3, which is which expression is equivalent to 2 times the square root of 48 minus the quantity 2 plus square root of 12 times the quantity 5 minus the square root of 12. So we see this here, and this automatically tells me that I need to FOIL, right? So let's write FOIL here. Remember, first, outer, inner, last. That doesn't go away in math. So let's go ahead and FOIL our terms out, keeping this negative here for now. We have 2 times 5 is going to be 10. 2 times the negative square root of 12 is going to be 2 square root of 12. And then we have 5 times the square root of 12. And then square root of 12 times square root of 12 is just going to be 12. Simplifying this further, we need to distribute this negative to all of our terms now. And yeah. So by doing that, we're going to get negative 10 plus 12 is going to be 2 minus 3 square root of 12. And then what we're left with, when we can simplify the square root of 48. So let's think about square root of 48 and some of the factors: 24 and 2, 6 and 4, 3, 2, 2, right? So take these out. It'll be 4 times 2, so 8, and that's going to leave square root of 3. And then again, 2. And if we simplify this, it becomes minus 6 square root of 3. So you get 2 square root of 3 plus 2. Again, what I did here is I took this 12, broke it down. We have a pair of 2, so we can pull that out. And that's how we get 6, because 3 times 2. Okay, now we have which expression is equivalent to the quantity negative square root of 8 times square root of 2 plus square root of negative 36. Well, we know anytime we take a square root of a negative, we're going to have an I. So this is going to be 6I, but we're positive now. And then 8 times 2 is going to give us square root of 16, and that's going to be negative. So negative 4 plus 6I would be your answer. Something you want to remember here is, of course, your I comes from taking the square root of a negative. That is your imaginary number. Continuing with I's, we're just asked which expression is equivalent to this one, and all that we're having to do is combine our like terms. Distributing this negative, and I see I. So we're going to get 23I. Negative 7 minus negative or minus 11 is going to be negative 18 plus 23I. Just because you have imaginary numbers does not mean combining like terms is any different, especially when all of your expressions are containing an imaginary number, all of your solutions. I would also say that a common mistake here is not distributing this negative. So if you forget to distribute that negative, you're going to get a totally different answer, one that's not even available here. Okay. Assuming the denominator does not equal 0, simplify the expression below. So what we have to do here is we need, just like anytime we're dealing with fractions, what does that mean? Well, we have to find a common denominator. The only way to do that is to multiply everything on this side by k plus 2. And then everything on this side by k minus 2. What you end up with, 5k squared plus 10k here, all over k plus 2, k minus 2. I'm not going to worry about FOIL here because there's really no point. Minus k squared minus 2k all over k plus 2, k minus 2. And then here, you're just combining your like terms. We have 5k squared minus k squared equals 4k squared. Then you have 10k minus a negative 2k plus b plus 12k. All over k plus 2, k minus 2. What we have here is still not an equivalent answer. So I see that both of these terms in my numerator here have a multiple of 4 and a k in common. So if I pull out or factor out a 4k, that leaves k plus 3 all over our usual denominator. And now you have your solution. Factor out that 4k. All right. All right, number 14. X minus 4 squared equals 28. Well, first what we need to do is we need to take the square root of both sides, rather than having to deal with any kind of binomial or intense polynomial. We'll just take the square root of both sides. And that'll leave us x minus 4 here. And a plus or minus 2 square root of 7. The reason we get that, again, 7 times 4. We have a pair of 2s that we can pull out. Anytime you take the square root, you're dealing with positive or negative. And because either one of those will give you 28. Solving for x, carrying over that 4, and you arrive at your answer. All right. Which solution set to the following equation, or what is the solution set to the following equation? So we're dealing with our quadratic formula. What I would do, if you haven't already, commit this to memory. A, B, C. So negative b represents the opposite of b, which is going to be 8. This would be negative 8 squared. So we get x equals 8 plus or minus negative 80 over 8. So 80 breaks down to 8 and 10, 5 and 2. So we have 2 and 2. So since we have 2 pairs of 2, we multiply those together, we get 4. We have to bring out that I because it's a negative. And then it leaves us with a 5 here. All over 8. Of course, this can simplify just a little bit further. You're going to get 2 plus or minus square root of 5 over 2. And that's because what we do is we factor out a 4. Because they both have a multiple of 4 in common. When you do that, everything simplifies. And that would be solution B. Okay. So anytime you're dealing with a square root, kind of like getting rid of a square root or getting rid of a square is taking the square root. Getting rid of a square root, you can take the square. You can square it. So we get a plus 9, negative 3 minus a. Okay. So when we factor this out, or sorry, when we FOIL this out, you're going to get this. Again, that would be negative 3 minus a. And this is how you arrive. Number. Well, definitely want to give you all that note. You don't want to forget that concept. So let's see what we can get rid of. Well, if I subtract 9 here and 9 here, that'll leave a equals 6a plus a squared minus an a is 0 equals a squared plus 5. Well, equals a squared plus 5a. If I factor out an a here, I leave a plus 5. And then these are equal to 0, so you have a equals 0. And then a plus 5. Now, if we were to plug 0 into this, though, it can't only equal negative 3. So there's only one solution that makes this work, and that's negative 5. And that's a good place to stop.